Hey, Bryce Carlins here from Robotics Competition News here at First Worlds 2017 in Houston. I'm here with Will from Team 2848 Allsparks. I noticed your team initially because of your two-gear auto, which is very unique. I haven't seen another one of those yet this season. And but when I got here, I was super enthralled by your robot and your process and your design and kind of how you worked at the beginning of the season. Can you talk to me a little about that?
Yeah, so kind of how we got here today is we really like to start off the season with developing some goals. We like to do some really rough prototypes with janky drills and wheels to look at some combinations. And so we ended up with kind of our strategy as an overall Gearbot as the highest priority. And then we made our drivetrain capable of maneuvering the field very well so that we could put up as many gears as possible. And then we also have the shooter. It's not as big of a focus on our team, but it's still there for an extra tie-breaking couple of points that might be critical in those 305 matches where you tie up 3 rotors, 3 hangs. So yeah, specifically, we have our drivetrain was a big focus this year. So we decided to go with a butterfly drive so that we could deal with defense. And so in the open field, it's really nice to have our Omni wheels down. So this is actually the butterfly drive in the robot. We have 4 of these. So instead of just 4 standard wheels, you have these modules. And it's actually driven off of this axle. And then you have a pneumatic cylinder that pushes down and engages the Omnis. So in the open field, it's really nice to be able to spin around defenders and be really maneuverable, and then turn those corners to get to the pegs. And then it's also nice to engage all 8 wheels on the robot when we are placing the gear when we're getting defended. As far as the intake goes, we really spent a lot of time tuning this guy. We went through a lot of iterations on this, and we ended up with something that intakes the gear with this first roller, and it pops in, and then it hits this back roller and pops up to the second one because it's spinning this way, and then it gets stuck right there. And so we actually have 3 sensors on this one. One is an encoder to track the rotation of it. So we actually have a position for starting position. We have one for the camera to be able to see the peg. And then we have our intake position as well. We also have a photo gate sensor, which detects when it's being broken by a flag that we have here. That basically acts as a virtual hard stop so that we don't ram into our phone and we just stop at the up position. It also resets the encoder for the rotation, so we're always accurate. Finally, there's a sensor that detects if a gear is in. It's another photo gate sensor. So when we put in a gear, we'll actually send a signal, to the back of the robot. It'll flash green when we have a gear in the robot, and then when it's red, we don't have a gear. That way the drivers can sort of see what's going on.
Even all the way across the field, because when it's facing the wrong way. Because when it's a floor intake and it's on the outside of your robot, it's impossible to see kind of how you're lining up. Yeah,
exactly. And so that's basically it for this guy. That sensor also tells it to stop the rollers in time, so it doesn't burn out the motors. So that's about it. And then the shooter, of course, we actually have a 2-roller shooter. Initially, we were going for the 3-channel shooter, but we kind of downgraded to be able to do it more accurately with the center channel. So that way we can get around 3 points in auto and also place the gear to give us some wiggle room for penalties and that sort of thing.
Right.
And then, yeah, I mean, one more important thing to point out, just with the overview, is we have a Android phone that we've hooked up using Android debugging software to communicate with the Rio. And so that's kind of an interesting thing that our team picked up this year. And we like it so far. So that's for tracking the peg.
Have you done any vision tracking in the past with like IP cams or the kind of the more traditional ways to do it?
Well, we actually do have a USB camera on here as well for tracking the gear in 2-gear Auton.
Okay.
It was kind of a last minute thing, so we wanted to go the easy route and use grip on this guy for the gears. So I could run over the 2-gear Auton if that's going to be interesting.
Yeah, I'd love to.
So we just do our normal center Auton, and then we back up and go turn 90 degrees and hope that the gear is in the right zone. It's kind of tough, but we did our best with this camera to actually track the gear and turn to get it. So it's about this kind of zone that's going to be that the gear can be placed in, which is pretty tricky sometimes. We're just able to get it under 15 seconds right on the peg. So that's pretty much the basics on that. Yeah.
So when you're using grip using grip with your USB cam, right?
Yeah.
And is that running bare on the Rio?
Yes. That is just minimally adjusted. We just tuned it in for during calibration time. We went in, tuned it up for this field, and looking forward to making a couple more.
So it's just tracking a polygon around the kind of the yellow about it.
Yep. We used a blur on the gear to get it to be more of a block sort of shape, which is a lot easier to track once you actually use the HSV tuning after it. And then you actually can get rid of some of the bigger areas reflecting off the Lexan. So you're able to create a minimum area and width on that gear, and then and we just track the center point on that.
Awesome, thank you. So to kind of shift gears, so to speak, you're machining on your custom shifting gearboxes. It looks like really nice. Can you talk a little bit about your fab process and your design process for your custom gearboxes?
Sure. So we've been through a couple iterations of this. This is designed in-house, and it's fabricated on a CNC mill that we've had. And basically, we have a 14 feet per second high gear and around 10 for low gear. So we're a pretty fast bot. We've run into some issues with high current draw, but this year it hasn't been too bad. It's a pretty smooth and tight gearbox. So, we have a couple designers on our team that focused on this in the summer, and we actually created a small West Coast style bot with a couple of these on it, and we tested it out and solved a couple of the problems along the way.
So a lot of the design process can happen in the off season before the event started?
I mean, the basic things like this, like we could probably put this into most types of robots. So we try to get a couple basic things done in the off season to give us a boost.
So what advantages have you seen with using like a custom shifting gearbox versus like a WCP shifting gearbox or like the new Vexpo shifting gearbox?
Yeah, so the whole point of creating this one rather than using West Coast Products one is to have them all, it's shorter in height. So you have 3 sims in series just side by side. So that way it's a shorter profile. And that's really nice when we have, our folding. This actually hinges up, the shooter does, so we can get into the base and put the battery in, and some pneumatics are in there. But it's nice for space reasons. We can make this a lower profile and sleeker, so we like it for that reason, primarily. Also, it's a lot easier to get the sims out. So if something's going to shatter. Hopefully not. We can get him out pretty easily with this guy too.
Awesome. Very cool. Anything else you want to hit on before you finish up?
Let's see. I think that's about it. Yeah.
Awesome. Thank you.
Thanks so much.